One of the most beautiful comparisons that makes us understand the true meaning of integration, which, as we agreed, is the calculation of the accumulation of areas. So now we'll see three functions on the left and their integrals on the right. Their integrals here should be the calculation of the accumulation of areas. At the beginning, we want to look at the constant function y equals 2. Now the function on the right will calculate for us the accumulation of areas. In the first step, if we move one step in the function on the right here, we have a rectangle. Here we calculated an area equal to 2. If we move a second step, we add the same value, the same area is added. That's why here we have a linear function. Its integral is a linear function because we jump by the same value. Here we jump by 2, here by 2, and so on. If we move a step, we again jump by the same area, 2, we reach 6, then 8. So this is the reason the integral of a constant function is the linear function. Now we go to the linear function, we want to integrate it. So we want to look at a comparison of the areas coming in here with the integral function, which is a quadratic function, x squared over 2. What differs here is that each time, if we look at the first time, we bring in a triangle. The second time, the area is higher than the one before it. The third time, the third step, the area is higher than the one before it, and so on. So here we have a continuous increase in the areas coming in, but this increase is constant. That's why here, if we look at the slope of the function, x squared, it's constant and continuous. Finally, we want to look at the exponential function. For the exponential function, we want to observe, again, the same thing, the areas coming in compared at each step. The first time we have this area, the second time we have an increase, the third time we have a larger and larger increase. So what differs in the exponential function is that the increase itself is increasing, whereas here the increase is constant, and here there's no increase, the same steps or the same values, we add them together. So this is the secret of the exponential function, that the increase in it is increasing. And when we delve deeper into the increase of the exponential function, we find it's linked to its current value, and this is a topic that leads us into E, the secrets of the exponential function. And the number E